introduction to my package, Package Finder. In this short video, you will learn what Package Finder is, what you can use it for, and how you can work with it in practice. Let us start with a quick overview of what you can do with Package Finder. As the name suggests, Package Finder is designed to find packages on the comprehensive R archive network. You can also use Package Finder to read detailed information about specific packages. Essentially, you get all the information that is available on the Packages CRAN website. Apart from that, you can also use Package Finder to learn more about new packages on CRAN, packages that have recently been published there. The interesting thing about Package Finder now is that you can do all these things directly from the R console. That means you don't have to leave the R console when you want to search for packages, to learn more about specific packages, or to see what is new on CRAN. You don't have to switch to your web browser, go to the R project website and look up all the information there. Instead, you can do everything right from the R console where you're working anyway. Since Package Finder is itself available on the comprehensive R archive network, you can download and install it from CRAN using the standard function install.packages. After you have installed Package Finder, let us now have a look at its main functions. The core function of Package Finder is the find package function. Find package is used to search for packages on CRAN. It searches your search term in the package's titles, short descriptions, and long descriptions. If you want to search in other fields, as for example the author field, then you should consider working with the Explore Fields function that is made exactly for this purpose. You can use the Package Details function to retrieve a profile of a specific package. Package Details provides you with all the metadata that is available on CRAN for this specific package. Finally, the What's New function lets you learn more about new packages that have recently been added to CRAN. This way, you easily find out if there are any new packages that might be of interest to you. Let's start with the find package function. The main argument of the find package function is keywords. Keywords is just a character vector of search terms that you want to search for. How these keywords are combined in your search is defined by the mode argument. If you set the mode argument to OR, which is also its default value, then all packages that match at least one of your keywords will be part of the search results. If, however, you set mode to AND, then only those packages will be among the search hits that match all of your keywords at the same time. With a case-sensitive argument, you can decide whether or not your search should be case-sensitive. The default value is false, so unless you demand otherwise, capitalization will not matter in your search. Next, you may want to decide where exactly your search results will be presented. You have two options, Viewer and Console. When you're working with RStudio, I recommend you use Viewer, because then the search results are presented in a nice graphical way in RStudio's Viewer window. If you're not using RStudio, choosing Viewer will usually open up your web browser and present the search results as a web page. Therefore, it might make sense to choose Console when you're working outside of RStudio. In this case, the search results would be presented in the R console as a text table. This is also a bit more in line with the philosophy of Package Finder, which is basically to enable you to search for packages directly from the R console without having to leave your usual work environment. Finally, you can decide whether or not you want the package's long descriptions be included in the search results. On the one hand, including the long descriptions may make the results somewhat less readable, but on the other hand, it gives you more information about the packages that you've found and makes it easier for you to decide which package is best for your purpose. Alright, let's now switch to the R console and look at some examples. Let's assume we want to find packages related to meta-regression. To find packages related to meta-regression, we search for the search terms meta and regression, and we want to connect these two keywords with a logical AND. AND means we only want to find packages that match both of these keywords. And that's all we need to do. Now Package Finder will go through the search index and find the packages that match our keywords. With currently over 14,000 packages on cron, this may take some seconds. But usually it does not take too long. 20 to 30 seconds is normally quite a reasonable time to expect. And here are the results. As you can see, we have found 28 packages out of the currently 14,266 packages on cron. Our search took 22 seconds. The top 15 results of our search are shown in the viewer window of RStudio. This number of search hits can be changed. We have an additional argument available called limit results. This argument allows you to decide how many search hits you want to see in the results. The default value is 15. Let's now have a closer look at the viewer window and the search results presented there. Of course, we get the package name and also a short description of the package. Apart from that, we see a score indicating how relevant this search hit is for our search. In the rightmost column, we see a number code. This is the Go number. It allows you to refer to this particular package later on when you use other functions like package details, for example. This was easy, wasn't it? Let's try another one. Let us assume, for this example, that we want to find packages related to structural equation models, SEMs. So we would call find package with SEM as our keyword. And here we go. Because we only have one keyword this time, we don't need to use the mode argument, which specifies how several different keywords shall be linked together. Alright, then let's see how the results look like. Wow, there are 455 packages that seem to include the keyword SEM. Let's have a closer look at the results. When we go through the results, we find packages like GSEM. The short description for this package says Semi-Supervised Generalized Structural Equation Modeling. Looks as if this package could be relevant for us when we work on structural equation models. But then we also have packages like this one or that one here. It is pretty clear that these packages are packages we would not want to find when we look for structural equation models. The problem here is obviously that for our search it does not matter if the matching part of the package's name is capitalized or not. Fortunately, this is something we can change. For this purpose, find package provides the case-sensitive argument. If we repeat our search, this time setting the case-sensitive argument to true, find package will only find packages that contain the phrase SEM in capitalized letters. Let's see, here are the results. 35 packages found. This time the results look much better. For example, this package here, SEMtree, refers to structural equation models in its short description. The GSEM package is again among our search results, and also a bunch of other packages that refer to structural equation models or SEMs. Now, So far, we have only presented the results with the package name and the short description. But as we know, we can also include the long description in the results. Let us try this. For this purpose, we repeat the search from before, but this time we include the results long desc argument and set this argument to true. Now you see we get the long description in our results. This allows us to better assess whether a package is relevant for our purposes or not. So finally, we have one argument left that we haven't tried so far, and that is the display argument. As you remember, the display argument allows you to decide where exactly you want your search results to be presented. Its default value is viewer, so the results are presented in the viewer window of RStudio. Let's modify our search and include the display argument. As you can see, this time the results are presented as a text table in the console. This table is also readable, but of course it is not as nice as the graphical presentation in the viewer. But, as I have mentioned before, it is a good alternative if you are not using RStudio and still want to work with Package Finder from the console. This was a quick tour of the main arguments of the find package function. If you take a look at the online help page for the find package function, you will see that find package has still some more arguments that we haven't discussed here. For example, the always sensitive argument. This argument can be used to specify search terms that shall always be treated as case sensitive, even though capitalization does not matter for the rest of your search terms. The weights argument lets you decide how exactly the scores that are presented as part of the search results are calculated. Particularly, you can set the weights for hits in the title, the short description, and the long description. The fourth value in the weights vector is a factor to scale the score when all of your search terms are found in the package's metadata. The default value is 2. That means that if all your keywords are found either in the package's name, short description, or long description, then the relevance of this package compared to the other packages is doubled. If you have now gone through your search results and have identified a package that looks interesting in your search then you can go and get more information about that package. For this purpose, Package Finder provides the Go function. The Go function allows you to open a package manual or to navigate to the website of the package, at least if the package has a website documented in the CRAN metadata. Go also allows you to request the details of the package, which will be shown in the R console. And even to install the package if you are convinced that this package is the right one for you. Instead of using the package name when working with the Go function, you can also specify the package by its Go number, the ID that is shown in the Find Package search results. By the way, when you want to return to your latest search results, you can always use the last results function. This function will just bring up the results of your last search. Now let's move on to the Explore Fields function. Explore Fields is the function that you would use to search for a search term in specific fields of the package's metadata. So while Find Package looks into the package's name, short description, and long description, Explore Fields lets you decide which fields you actually want to search in. First of all, let's start again with a quick overview of the main arguments of that function. The most important argument of the explore fields function is term. Term is the keyword that you're looking for, and at this time it is really only one keyword. You cannot specify a vector of keywords here, you can only look for one keyword at a time. But don't worry, this limitation is likely to be lifted in the future. Second important argument of the function is fields. Fields is the vector of package metadata fields that you want your keyword to be searched in. You will find a list of the available fields in the online help for the explore fields function. Next, we have the mode argument. The mode argument decides if a keyword needs to be found in at least one of the fields that you have specified in the fields argument, then the mode is or if the keyword needs to be found in all the fields that you have specified in the fields argument. In this case, you would set the mode argument to and. With the match argument, you can decide whether the search term must match the whole contents of the field or if a partial match qualifies too. Again, the display argument allows you to choose between the viewer window and the console for presenting the search results. Let's have a look at an example. Assume that we want to find packages where Hadley Wickham is either the maintainer or the author of the package or both. To perform the search, we would work with the explore fields function and use Hadley as our search term. Then we specify the fields in which we want to look for the search term, and in our case, this will be the fields maintainer, authors at R, and author. And here are the results. Now let's move on to the package details function. The package details function is designed to provide you with important information on specific packages. It is very simple to use. You only have to specify the package that you want to get information for. To specify the package, you can either refer to the package by its name or by the Go number from the search results. As you may remember, this Go number is the rightmost column of the search results that you produce with the find package function. So you can choose how you want to specify the package, either by its name or by its Go number. Obviously, the argument package is a required argument. You can't do without it. The second argument, brief, however, is an optional argument. If brief is false, then all available information for the specified package is presented. This may be a lot more than you actually want to see. So if you want to reduce the information presented to the package title, short and long description, plus the maintainer of the package, then you can set the argument brief to true. Let's try it out. Assume that we want to get some information on the ggplot2 package, the well-known graphics package. Then we can just enter package details ggplot2. And this will provide us with all the information available on the ggplot2 package. As you can see, there is quite a lot of information available from the CRAN website of the package. To shorten this a bit, we can call package details again, but this time we add the brief argument and set this argument to true. This makes the whole output a bit more readable and focuses on the most important information. Alright, this is it for package details. Finally, let's have a quick look at the fourth main function of Package Finder. This function is What's New. As the name suggests, What's New gives you information about packages that have recently been published on CRAN. So, not surprisingly, the main argument of the find package function is last days. Last days allows us to specify how many days we want to go back in CRAN's upload history. If you specify last days as 0, which is also the default value, then you will only see packages that have been added to cron today. Again, an argument brief lets you decide whether you want to see the full information or a shortened version, which is the default. Let's now see how that works in practice. Here we call what's new without any arguments. So we want to see the packages that have been published on cron today. And as you can see, there are quite some packages that have been added to cron today. Of course, you could easily explore each of these packages further by working with the Go function and, for example, go to the package's website or open its PDF manual. Alright, this is it for the introduction. I hope you enjoyed this brief tour of the Package Finder package. But there is still more to know. For example, how to work with a custom-built search index that also include all the package's download figures. So if you want to learn more, I recommend you go and read the full online tutorial. Of course, I would also appreciate your contributions to improve the package and add new functionality that makes it even more useful and valuable to its users. So, see you on GitHub. If you want to stay up to date on Package Finder and other packages that I've developed, then follow me on Twitter. Thanks for watching. Enjoy working with Package Finder.